let's see now how to perform the classification of cells after we have performed the segmentation using, of course, the SCHELI plugin. So here as input, we have the previously created individual folder full of CSV data, one file for each image analyzed. We can see here that we have the vessels, some with the label border if they touch the border, and then the cells nucleus 1, cytoplasm 1, cell 1, 1 being the ID. So these components are all from the same cell. Then same thing nucleus 2, cytoplasm 2, cell 2, and same thing if they touch the border, a label underscore border will be added. And then we can see all of the measurements performed automatically by ImageJ, as well as some custom measurements such as the vessel distance, which is the distance to the closest vessel, the name to identify which one was the closest vessel to that cell or to that vessel as well. The closest neighbor, so the closest cell to the one we are analyzing, and the name of that cell to know which one it is. Using all of these measurements, which are about mm, the surroundings of the cell, about its shape, about its color, about its size, we can then use all of this information to train a new XGB model. And we can do this here in train. So let's see again the parameters. We have input, which should be the uh, s- CSV data slash individual. Then the output directory, we can choose it whatever we want. For this example, I can choose here 03 model. And then the JSON file with the classification. Well, what is this file? It's simply what we can create here. So we should choose the image folder, the original one with all of our images. Then here we choose the file with all of the cells individual, and simply start selecting from here the image with its relative cells. We can select the same scale used as before, and from here we can start creating our classes and assigning cells to those classes. So for example, I want to create the class hepatocytes. I add it and select it and start adding cells to it. Well, if I do not like this visualization, I can set here the parameters, so the border width to make them pop up more. The opacity, I can make it to 1, so it's fully opaque. Uh, or if I want, I can click the keyboard, the key on the keyboard E, and they will disappear momentarily. So yeah, this is simply to help us select with the most accuracy. If I want some other classes to be created, I can also assign custom color to better help me distinguish between them. So for example, in this case, I want a completely blue class. Let's call it NPC, which stands for non-parenchymatous cell, and let's add it. So now I can start selecting the cells here. For example, I do not see quite well which cells are which, and so I can zoom in and move around. And for example, I'm pretty sure this is not a hepatocyte, and I can select it and go on like this. Uh, Also, let's see, for example, if we have some class to ignore. Let's see, they are false positives. Let's add it. And here we can select them. For example, here there's nothing, here there's nothing, and so on. And I can make the analysis more accurate in this way. If if I am done selecting some cells from this image, I can move to some other image as well. For example, if I want some infiltrate, I know that it's in this image, for example. And yeah, I can see, hey, here there's an infiltrate. Let me select it, infiltrate. Let me assign a new custom color. Let's put it in yellow. So yeah, mm, yellow. Sorry, this is green, this is yellow. Uh, 255. And yeah, add class. And start selecting, oh, sorry, infiltrate. Start selecting everything. Yeah, this one is maybe a hepatocyte because it's round. No, doesn't look like this. Yeah, and simply keep going on selecting everything. So after I finish, or if I want to take a break and keep the classification ongoing for tomorrow, I can save it. And yeah, simply it will be saved as cell classification. And if I want to keep adding to my classification tomorrow, I can just come another day with select again the two folders. First one with images, second one with individual CSV data. And let's see, 3 to 1, select the scale. And yeah, the progress is not here because we have to first load the classification. Let's go to the downloads. Uh, if there is no error, everything should be saved correctly. And here we have our selection from the day before. Then, when we finish with our selection and we are satisfied, we can just go here, select the cells, and browse for that file that we just created. So let's see, downloads, cell classification 1. And now we can go to see the other parameters. Train ratio. This is simply for evaluation. Not all of the cells that you are selecting are going to be used to train the model. Some of them are going to be used to test it and see if the model is good at classifying cells that it has never seen. So this is simply the ratio. For example, putting it at 90, it means that 90% of the cells will be used to train the model, while 10% of them will be used to test it. Parameters, this is more complicated. We are going into the machine learning field. One of the most important parameters is learning rate. The smaller the value, the slower the calculation it will be, but also the most precise it will be. The number of trees, the more we have, again, the longer it will take, but also the result will be more accurate. And the max depth, this also gives us more accurate results. But there's with these two, especially with max depth and also with number of trees, we could go um, have another problem. Yeah, the result will be really accurate, but it will be overfit. So the model will learn really, really well to classify the cells in our training data, but then when testing, it will assign them wrongly. This is a common problem in machine learning, which is overfitting. So do not overdo it, even if you have a powerful computer. Uh, so yeah, cells subsample and feature subsample. Again, it's how many cells and features will be used for the analysis, for the training of the model. And then lambda, alpha, and gamma are really specific settings for the XGBoost model. Features. Here we can choose what we want, which measurements done by Fiji do we want to use for the analysis. Uh, for example, I know that, I don't know, the ferret X and ferret Y might not give us any meaningful information about the cells. I can deactivate them. Deactivating features not only gets us a faster calculation, but also decreases the risk of overfitting. So the model might find some information that doesn't exist in these parameters and will wrongly assign the cells based on that. We can use our scientific and clinical knowledge to only select the features that we like the most. So here are divided into a logical order. So first we have the surrounding features, which are the same for the cell, nucleus, and cytoplasm. So for the analysis, only one should be active. If we activate all three of them, it will simply take longer without any benefit. And then we have the size parameters. So the area, the perimeter, the width, height, um, which are pretty intuitive what they mean. The major and minor are simply if we approximate the ROI with the nucleus, it's easier to visualize. If we approximate it mathematically to being an ellipse, then simply this will be the major and minor angle of that ellipse. The angle will be the angle between these two axes, so to know the orientation more or less. Then we have the shape. We have this shape indicator, so circularity, solidity, roundness, aspect ratio, and ferret angle, as well as ferret and mid-ferret. All give us some information about the shape, more or less. While the ferret max and ferret min also give us some information about the size. Then we have the color variables. So mean is simply the grayscale mean average, the grayscale mean of the nucleus of the cell of the cytoplasm, with standard deviation, mode, mean, max. All of these are calculated as being the distribution of image of color intensities. This is calculated 3 times. Once on a grayscale image, once on the hematoxylin deconvoluted image, and one on the eosin deconvoluted image. So in total, we have around 130 total features, and this allows for a more personalized analysis. The output, again, we can select the US or EU format, whichever works best for our Excel. Uh, of course, if you have used one format for the segmentation, you should stick to it and use the same format for the training of the classifier as well. So let's see if it works with the few cells we have created, if just around 5, 6 cells that we have selected are enough. Yep, it worked well, and it saved everything in the folder. So let's see, where is the folder that we selected as output? This one. And here we have the model, which is a JSON file. This can be seen also with some text editors. Yeah, me format document, and it gives us some information if we want to read about it. This is more for technical people. Um, yeah. So not only do we have the model, we also have some results. So let's see how well did it do. Well, not that great um, since we only selected a few a few cells. So as you can see, the training set was 13 cells. It was tested on one cell, and so yeah, it's not great at precision, recall, or F1 score. Yeah. The number of cells that you should select should be at least, that's nothing scientific at all, but as a rule of thumb, around 20 cells for each feature that you select. So with around 130 features, yeah, there are a lot of cells that you have to click on. And yeah, after after doing this, after training the model, we can use it. So let's select it. Where where is it? Uh, in yeah. Um, okay, here it is. We can select the model we just created. Then we should select the Okay, so now that we have finished training our model, we can use it to classify new data. So let's see. Here, the first file is our model.json that we have just created, which is here. Let's select it. Then let's select the CSV file containing all of the cells that we want to segment. It might be the individual files, the individual CSV files. It might be some from another old analysis done using the same parameters. Just it has to have the same format and the same parameters, more or less. If not, the accuracy will go down and the testing results will not be accurate at all. So let's select it. Let's select the new output. We want to put it here in the final CSV. Um, and for details, we can select the JSON file with our cells, the one we created here. So after doing that, we can click OK. It will take around 2 minutes at most, and then we will have a file like this with all of our cells. Uh, it joins together all of the files from the individual CSV folder. So the final result, it's pretty big if you have a lot of cells. Yeah, and here you can see we have the class. This is a previous analysis I had done, and we have, for example, from the file P1, this stuff, cell 1 is hepatocytes. This is the accuracy that it is a hepatocyte, and here are the probabilities for each class. So for this cell, our model was 95% certain that it was a hepatocyte. 0.3% sure it was infiltrate, 3% sure it was some other non-parenchymatous cell, and 0.08% sure it had to be ignored. And yeah, then we have all of the measurements to then use them for whatever statistical analysis we want. And we can count here, for example, if I go at the end, I can see how many cells are for each one. So here are the percentages. And yeah, we can see the percentage of the cells in all images. And if we want, using Excel, using some other file, we can do some more complex analysis. If we want to see graphically if our model performed everything correctly and not only by trusting the the performance metrics in this txt file, we can again go here on the SCHELI website, on the cell visualizer, and then again we select the folder with all of our images. Let's upload it. And let's upload also the final CSV with all of our data. Now we can select the image. We select the scale. Okay, so here we can see the cells, and we can see if they were segmented correctly or not. Let's see again the infiltrate, if it was segmented correctly or not. And yeah, as we can see, everything seems to be done correctly. Um, and this is it. You can then use all of this information for whatever statistical analysis.